Hello and welcome. In this tutorial we're going to build this feedback texture displacement. We're going to start with an almost empty max patch. The only thing I've already created are this jit.world object because we're working with textures and with jit.gl.pix, so we need some kind of GLSL rendering context. I've also created a jit.p window so we can see what we're doing. And here I have a input video for our feedback effect. So this tutorial roughly consists of 3 parts. The first one is setting up our feedback system. The second one is displacing our texture, our input texture within this feedback system. And the third one is getting creative with what we built. So let's start with the first one. So I'm setting up the feedback system now. I'm using a texture dimensions HD, so 1920 by 1080 at depth 0. So it's not changing, and at type float 32, which is important when working with feedback. So I need 2 of those. Then I'm also using a it's not so easy, so that's what I need, and jit.gl.codebox. If you're not working in Max 9, then what are you doing? No, if you're not working in Max 9, you don't have this jit.gl.pix.codebox available. You can just work with a regular jit.gl.pix object and then create the codebox in here, and everything else should be pretty much the same. So in our codebox, first I'm going to assign inlets and outlets, and then we'll go from there. So first I'll have the picture in, which is the main input texture, which is coming from this video. And we assign this to input 1. Then we have the feedback in. We'll assign this to input 2. So this is going to be this texture. Then, I'm going to assign an output color, which is just the final finished texture that is then sent on the one hand to our jit.p window. So we can see the result of what we're doing, and on the other hand, it's going to get sent to this texture, which is then the feedback loop. So, but for now, I can just assign it to our picture in, and then I'm creating outlet 1, which is going to be the out color, and out 2 is also the out color. I mean, you can see that this is a bit redundant because we're sending the same texture to 2 outputs. But I'm doing this because it's easier to see what's happening. The patch is tidier, and it's kind of more explicit what texture is going where. So then we can create our patch chords first. So this is the input video into this texture, becoming picture in, and here output 1, out color, going to our jit.world. Let's align this so it looks a bit nicer. So this should already be working. Yeah, we can see that this is just going through this whole thing. And here with the feedback in, I'm using outlet 2, which is this one, sending it to this texture and sending it back here. There are many ways to do this kind of feedback texture processing thing in Max. This is just one of them, and it's one that works very well for me. That's why I'm working with these 2 textures here and with these 2 outlets here. So now that we have set up our feedback system, we can go into the texture displacement. And what I want to do is essentially creating a mixture of the input texture and the feedback texture and displacing it a certain amount on every frame. So something is coming in, we'll displace it a certain amount, so move it around. Then it's coming back again here. And the same process is applied over and over again, like an infinite iterative process. So let's first take a look at how can we displace a texture. We're going to use the sample object for that. So I'm going to set this output color to sample picture in normalized coordinates. So this should still be working. So normalized coordinates are coordinates that are ranging from 0 to 1 on the x-axis. I'm going to assign it here real quickly. 0 to 1 on the x-axis, represented by the red channel here, and 0 to 1 on the y-axis, represented by the green channel here. And if we're just using these normalized coordinates, every pixel from the input texture is essentially going to get assigned to its original position. If you want to move the texture around, we need to introduce some kind of offset. So, for example, if I'm moving it 0.5 in the x direction and 0 in the y direction, I get an error for some reason. Because I forgot to add this here. So now you can see that the texture gets moved in the x direction. I can also, 0.25, and it's also moved in the y direction. But applying this displacement like this with x and y coordinates is not very intuitive. So what I would like to do is to work with polar coordinates. So I'm creating, or I'm using an angle and a distance, and then turning this pair of angle and distance into our x and y coordinates, and then displacing the texture according to those coordinates. Yeah, so to do this, I'm going to declare a parameter up here. So the difference between a regular variable and a parameter is that this parameter can be accessed from outside the jit.gl.pix.codebox, which is what I want to do now. So first we'll have our angle, and let's say it's initially 180 degrees. And the second parameter is our distance. Let's say we'll start with a distance of 3. Yeah. To get from angle and distance to x and y coordinates. Okay, let's put this up here and start from here. Yeah, so to get from angle and distance to x and y coordinates, we can use sine and cosine. So the x position would be the cosine of our angle times pi. But the thing is here, cosine and sine work with not with degrees, but with radians. And to get from radians to degrees, I'm dividing this angle by 180 and multiplying it by pi. The thing is, it looks a bit redundant. I could just define our angle here in pi, and then I wouldn't have to divide it by 180, but I think it's much more intuitive to work with angles that are in degrees, and then doing this transformation here instead of just writing something like 2 pi in here. Okay, so but we're not done yet, because this gives us just the x position on the unit circle around our pixel. So we still have to apply our distance. So we're multiplying this by the distance, and so we have the angle, so 180 degrees at the distance of 3. But we're not quite done yet, because if we're again introducing a an offset here. You can see if I introduce an offset of 1, nothing really changes here because we're working with normalized coordinates. So the maximum offset is already 1. So when we're applying 1 as an offset, the whole thing like wraps around from the other side. So we need to introduce an offset that is between 0 and 1. So what I like to do is define our distance in terms of the size of 1 pixel. So if I have a distance of 3, this means that I want to displace the texture at every frame at a distance of 3 pixels. So to get from this integer to pixels, I have to multiply it by the size of 1 pixel. So how do I get the size of 1 pixel? I just take 1 and divide it by the dimension of the whole texture. So this would mean for the X size, 1 divided by 1920, and for the Y size, 1 divided by 1080. And this gives us the size of 1 pixel. So I'll call this pixel. And multiply our distance by the pixel. And so what's happening now is we get the X position for our angle at the distance of 3 pixels. The same thing we can do for our Y displacement. The only thing that's different is that we're not using the cosine, but the sine. And then I can create a variable called, let's call it just offset. And put our X and Y in here. I think I got a... No, that was from earlier, so no errors yet. And then I can add this offset to our normalized coordinates. So nothing is visibly happening. So I'm going to assign the angle here from outside and the distance here from the outside, so we can increase the distance. And now you can see the whole thing is shifting at different angles. Yeah. But as you can see, we're only applying it to the input texture. What I want to do next is to apply it to a mixture or a combination of input texture and feedback texture so that the whole texture gets moved a certain amount each frame. So to do this, I'm going to create another parameter called, let's just call it feedback, set it to 0.9. And for our output color, I'm going to, how will I do this? Okay, first I'm going to reassign this feedback texture here as the feedback plus offset. So feedback is going to be, so the texture we call feedback texture is going to be the texture that's coming in here with this X and Y offset. And then I'm going to assign or create output color and say this is mix of picture in and feedback in, and it's controlled by our feedback parameter. So what this operator does is it takes two variables or two textures and does a linear interpolation, which means if this feedback variable is 0, then we would get 100% of the input picture and 0% of the feedback picture or feedback texture. If this is 1, we would get 100% of this and 0% of this, and everything between 0 and 1 are different linear interpolations between the two of them. So now we have set this to 0.9. So on every frame, we would get 10% of the original picture coming in and 90% of the feedback texture, which is then going to get displaced at every frame. So you can see there's quite a lot going on because the distance is so high. But if we say we want a distance of 3 pixels, you can see that the whole thing is looking blurred out, smeared out, moving in this direction. So I'm searching for here we have the feedback. We can set this to 0.99. So there is more of the feedback coming in. You can play around with these values. You just shouldn't go over 1 because then it kind of explodes, as you can see here. So let's keep it at 0.99. Okay, it's still exploding, so I'm going to clear this texture and this texture. Going to 0.99. Yeah, now it should be working. This is what we want to see. And now we can apply different angles, so it's smearing in different directions and different distances, so it's more or less displacement for each frame. So yeah, this was part 2 or the second part of what we wanted to do. We have now a way to, in this feedback system, displace our texture. And the thing is, yeah, it's already a pretty nice effect to look at, but what I want to do is something that's a little more complex, because here, as you can see, we have the same distance and the same angle and the same feedback for every pixel of the incoming texture. What I would like to do now is use the input, or probably better to use the feedback texture as a control for the distance or the feedback or the angle. Let's start with the angle. That's going to that's the most interesting, I think. So that for that the angle for each displacement, or that the angle for the displacement of each pixel is controlled by the texture itself. So how can we do this? I'm going to assign a new variable, call it control, and set it to our feedback in. And yeah, I don't just want to control it by the color values of each pixel, but just by the brightness. So I want just to get the brightness of the feedback in, and to do this, there is this function RGB to HSL, which turns the RGB values to hue, saturation, and brightness of each pixel. And to get the brightness, I'm just saying I want the Z component of this vector. And now the control variable is essentially the brightness of each of the feedback pixels. Now, instead of using the angle from the outside, I'm going to clear this away, and I'm going to put this control texture in. So what this means is that for each pixel, the angle at which it moves is different, or is dependent on what's coming in here. And this is looking pretty nice, because depending on how bright the pixels are that are coming in, the angle of movement is changing. And I could also say, I mean, I can still change the distance. So this is maybe a bit extreme. Let's keep it at this distance. And what I could also do is, these angles go from 0 to 180, I think. So if we multiply this by some factor, let's say by 5, it should get more swirly because the angles are getting bigger and bigger. So you can see the higher this number, the more swirly it kind of gets. And you can see the colors are bleeding into each other. And we have this nice, really organic looking feedback system. But let's maybe leave it at 2. That looks pretty cool. Yeah, you could also, instead of controlling the angle or changing the angle for each of the pixels independently, you could also change the distance. So I could again say this is going to be the angle divided by 180. No, that's wrong. Angle, so that should work. So angle here, and then multiply it by the control as the distance. So same angle, different distance for each pixel. Yeah, that doesn't do too much for me, so I'm going to change it back. You could also say that, I don't know, control 2 is the x value, which would be the hue of the pixel, and then this x value could control, for example, the amount of feedback which is happening down here. What's happening here? Nothing. Okay, what about we multiply this? No, then it's exploding, so maybe we can multiply it and then clamp it so it doesn't go over 1, which would look like this. Control 2, 0 and 0.99. And yeah, that's the thing with feedback systems. If you're not careful, they can blow up. Yeah, how about this? You can see the feedback is controlled by the hue of the texture that's coming in. Yeah, but that's essentially this dynamic color swirl. I hope you found this useful. Thanks for watching.